All right, we're going to go ahead and start on the review for our test on volume and surface area. So looking at the first part, we're going to look at the part that's dealing with volume. Question number one asks us to find the volume of each figure. And then, so let's take a look at number one. The first thing we need to do is identify what shape it is. Remember that a lot of our shapes are identified on our reference sheet. So we want to make sure we are figuring that out. So first of all, since we have two parallel bases on the top and the bottom that are both congruent and parallel, and that means this is a prism. So the volume of a prism is area of the base times the height. Well, the shape of the base, it's hard to see because they don't really have dashes on here, but this is the base. The base is a rectangle or a parallelogram. And we know that the area of a parallelogram is base times height. So in this case, it would be 8 times 9. So that's the base. That's this figure down here at the bottom. It is 8 times 9. And then the height of that figure is 13, the height of the prism, meaning the distance between the two parallel bases. All right, so then we're just going to use our calculator at this point and do the calculations. And so we do 8 times 9 times 13, which in this case is 936 is the volume. All right, let's take a look at the next figure, number two. This is a right circular cylinder. So the volume on a right circular cylinder is area of the base times the height, just like the volume of the prism was. So in this case, the base, of course, the circular base right here, we have like a base down at the bottom too. So this is the base, and the base, top base and bottom base are parallel and congruent to each other. So the area of that base is a circle, pi r squared. So pi times 7 squared. And then the height of that cylinder is 11, right? So it did say in the directions that we are going to give answers in both forms of pi and decimal. So we're going to start with our pi answer. So using our calculator, 7 squared is 49. So 49 times 11 is 539. So our answer in terms of pi would be 539 pi. Now, as a decimal, we need to figure out what is 539 times pi as a decimal. So 539 times, there's a pi key on your calculator, and then you push equals. And so it didn't say how to round it. So we're going to round it to the nearest hundredth. So looking at this, we have 1693.318. Since that 8 is 5 or more, we're going to make it 32. So 1693.32 is the decimal answer to this volume problem. This is a 9, just in case you can't see. All right, let's continue on now with number three. Number three, we have now a pyramid. So the volume of a pyramid on your reference sheet, it says 1/3 times the area of the base times the height. Now this is a square pyramid. So on the bottom, because here is the shape of the base right here, the square would be 12 times 12. That's the area of the base. So we're going to do volume is 1/3. Area of the base is 12 times 12, base times height. And then the height of the pyramid is 8. Okay, so we're going to get our calculator and we are going to do 1/3. Now, the calculator I'm using on the screen is just the Windows calculator. It doesn't have a fraction key. You all do have a fraction key, so you could literally type 1 fraction key 3, then times 12 times 12 times 8. So what I'm going to do is 12 times 12 is 144, and then we're going to multiply it by 8. And then multiplying by 1/3 is like multiplying by 1 and dividing by 3. Okay, so that ends out to be that the volume of this is 384 cubic units. They didn't include any units, so we're just going to assume these are all just in units. So cubic units would be the volume. If we're talking about area, volume, we're talking about cubic units. All right, number 4 is another, in number 4, we have another prism, because the prism has parallel triangles. This front triangle and this back triangle are parallel and congruent to each other. So these right here are the bases, the parallel and congruent bases. Okay, so volume of a prism is area of the base times the height again. All right. In a triangle, remember that is base times height divided by 2. Here's your base, here's your height, and then divided by 2. So 4 times 3 divided by 2. And then the actual height of the prism, that means the distance between the parallel and congruent bases. So the height of the prism is 15. So be really careful with that. Even though the figure is laying on this side, the height is not really 3. It's the distance between the parallel and congruent bases. So we're going to use our calculator again. 4 times 3 divided by 2. So the area of the base is 6, and then we're going to multiply by the height of the prism, which is 15. So this gives us a volume of 90. Okay. All right, let's take a look at now number 5. On number 5, we are moving toward a little different figures. Again, they're asking us to find the volume of a sphere in this case. So the sphere is 4/3 pi r cubed. That's what is written on your reference sheet. You may have a teacher that does 4 times pi times r cubed and then divided by 3. That also works as well. But this is what's given to you on your reference sheet. Our radius is given to us. It is 6. So we're just going to plug in 6 for r. Okay. All right. So once again, we do need to give our answers in terms of pi and also as a decimal. So let's start with answers in terms of pi. I'm going to do the 6 to the third part first. Now, again, you all have the approved scientific calculator that has a fraction button on it. So you can do 4 fraction key 3 and then multiply by 6 to the third power. Now, both of my calculator and the approved calculator has an exponent key on it, and it looks like this. Your location might be in a little different than the calculator I'm using. But anyhow, this is an exponent key, x to the y power. So if I do 6 to the third power, I'm going to do 6, exponent key 3, and that is 216. All right, and then I'm going to multiply by 4/3. Since I don't have a fraction key, I'm going to multiply by 4 and then divide by 3. And so the volume of this sphere is 288 pi cubic units. All right. Now, they also did again ask for a decimal answer. So because they did that, I'm going to do 288 times pi key equals, and again, we're going to round to the nearest hundredth because they didn't tell us what to round to. So 904.778, that 8 means it's going to become 904.78. So the volume is approximately 904.78 cubic units as well. All right, so this one's going to be a little bit more challenging. We have a cone, a right circular cone. The base is, of course, the circle on the bottom. The diameter of the base is 10, and then they give us a slant height. But the volume of a cone or a pyramid is 1/3 area of the base times the height. So the area of the base, it's a circle, that's pi r squared. So if the diameter is 10, then that means the radius would be half of that, which is 5. So we're going to bring down the 1/3. The area of the base is pi times 5 squared. And then the height of the pyramid. So that's going to require a little work because I don't know what the height of this pyramid is. I know that this is a right triangle and this is 5. So 8 squared plus 5 squared equals 13 squared. We could use the Pythagorean theorem because, again, this is a right triangle right here. So I'm going to have to squeeze this in. I'm sorry about that. 8 squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. Okay, I'm going to subtract 144 from both sides. And so we get 25, and then we're going to take the square root of 25. So the height of this cone is, oh, I'm sorry. I messed that up. Let me go back a minute. I'm sorry. Doing things in the wrong. I'm solving the problem because I kind of know what the answer was. Let me go back and try that again on the height. Sorry about that. So it's 8 squared plus 5 squared equals 13 squared. 8 squared plus 5 squared equals 13 squared. So 5 squared, this is a square. So 5 squared is 25. 13 squared is 169. So now, let me erase a little more cleanly. I'm going to subtract 25 from both sides. So h squared equals 144. And now I'm going to take the square root of 144. So the height is 12. So now 1/3 area of the base, and then the height is 12. That's what goes there for this height right here. Okay. All right. So now, again, we need our answers in terms of pi and also as a decimal. So we're going to do 1/3, then times 25, because 5 squared is 25, and then times 12. Now, in my calculator, again, I don't have a fraction button. So what I'm going to do is 25 first, times 12, and then times 1/3, which is really times 1, and then divided by 3. So I get that the volume of this cone is 100 pi cubic units. And then I need to get a decimal answer for that. So I'm going to do 100 times pi key equals, now it says 314.159. That 9 is going to become, make this 314.16. Okay. All right, number 7. Number 7 is very much like number 1. So volume is, this is a prism, and we know this is a prism because we have parallel bases and parallel and congruent bases here. So here is the base right here. And so the volume is area of the base times the height. Base times height for the base area. And then the height of the prism, that's the distance between these parallel faces, that would be 17. Sorry about that. All right, so 3 times 5 times 17. That's all we have to do here. 3 times 5 times 17, and we get 255. Okay. All right, continuing on with number 8. Okay, number 8, we're asked to find the volume of this cylinder again. Volume is area of the base times the height. So the base is circular with a diameter of 12, so you got to be careful. Remember, area of the base is pi r squared, so pi times 6 squared, because if the diameter is 12, then the radius would be half of 12, which is 6. And then the height, this is the distance between the circular bases. So we have these circular bases here and here. Though they're the bases because they're parallel and congruent. The height is the distance between the bases, so the height would be 20. Okay. All right, so we're going to do in the calculator. First, we're going to get a pi answer. So 6 squared is 36 times 20 is 720. 720 pi is our volume in terms of pi. And then as a decimal, we're going to do 720 times pi key. And we get 2261.946. That 6 means I'm rounding 94 up to 95. So 2261.95. All right, number nine. Number nine, we have a hemisphere, half of a sphere. So we know from our reference sheet that the volume of a sphere is 4/3 pi r cubed, but we don't have a sphere. We have half of a sphere. So we would have to divide that by 2. Okay. We know that the radius is 9. That's given to us. So we're just going to plug that in now. 4/3 times pi times 9 cubed and then divide by 2. Again, yeah, your calculator is a little better than the one I'm using on the computer screen. 4/3, you can type in 4 fraction key 3, and then times 9 to the third power. Remember, this is this x to the y key. It's in a different location on your calculator. I believe it's on the right side, but this is your exponent key. And then you're going to divide by 2 and then tack on a pi. So what I'm going to do is I'm going to do the exponent part first. 9 to the third power is 729. Then I'm going to divide by 2. And then I'm going to multiply by 4/3. So multiply by 4/3, that would be times 4, and then divide by 3. We get 486. So in terms of pi, this is 486 pi. Oh, wait a minute. I think I forgot to divide by 2. Let me just double check that. Maybe I did, and maybe I didn't. I'm going to do that one more time. 9 to the third, and then times 4/3. Actually, I think I did. And then divided by 2. Yes. Okay, so 486 pi. Yes, that is the right answer in terms of pi. As a decimal, I'm going to do 486 times the pi key. So 486 times pi key. And looking at this calculator, 1526.814, since that 4 is less than 5, I'm just going to do 0.81. So 1526.81 is the volume in as a decimal. All right, continuing on. We're going to take a look at number 11. It says find the volume of a sphere with diameter 24 meters. So remember, volume of a sphere, 4/3 pi r cubed. Well, the diameter is 24, so that would mean the radius is half of that, which is 12. All right, so we're going to do 4/3 times pi times 12 to the third power. All right, so again, we're going to answer in terms of pi, and then we will answer as a decimal. So I'm going to do on my calculator 12 to the third power first, which is 1728, and then I'm going to multiply by 4/3. And so we get 2304, 2304 pi. Since they did actually give us meters, this would be cubic meters or meters cubed. And then I'm going to take that and I'm going to multiply it by the pi key. And I get this long decimal right here, 7238.229. That means it's going to go up to 23. 7238. So this is 7,238.23 meters cubed. Okay. All right, let's take a look at now the next one, number 12. It says find the volume. Okay, so this time we have a composite figure. We have a cylinder and a hemisphere that shares a common circular base. So we have to do the volume of the cylinder, which is pi r squared. Whoops, I'm sorry. Let's try that again. Volume of the cylinder is area of the base times the height. And then the volume of the hemisphere is 4/3 pi r cubed, but divided by 2 because it's half of a sphere. All right, so let's plug these things in, starting with the base area of the cylinder. If the diameter of the cylinder is 6, then the radius is going to be 3. So pi times 3 squared. And then the height, now we're talking about this distance right here. This is going to be 30. Okay, and then I have to add to that the volume of the hemisphere, 4/3 times pi times the radius. Again, if the diameter is 6, then that really means the radius is just 3. So pi times 3 cubed, but then we don't forget we have to divide by 2 because this is a hemisphere. All right, so we're going to work this out now. 3 squared is 9, so 9 times 30 is 270. So the volume of the cylinder is 270 pi. Okay, now we're going to do the volume of the hemisphere. So we're going to do 3 to the third power, 3 exponent key 3 to the third power. That's 27. Then times 4/3, and then divide by 2. So the volume of the hemisphere is 18 pi. So these are like terms. So like if I was doing 270x plus 18x like you did in Algebra 1, you would combine like terms. Well, that's what we're doing here. 270 plus 18 is 288 pi. So this is the volume in terms of pi. Then in terms of it as a decimal, so I'm going to use my calculator now, and I'm going to do 288 times pi key. All right, it says 904.778. So that would be 904.78 because we're going to round that 77 up to 78. All right. So we're going to continue on now because that was the volume part. Here's the next part of the review. The next part of the review first starts with some three-dimensional stuff, and then we go to surface area. All right, so naming these figures. So again, if they don't do this, which they don't have to do, but a lot of drawings will do this. They'll dash in the parts you can't see behind the figure or on the bottom of the figure. So this has a rectangle on the top and a rectangle on the bottom. So this is called a right because the top is directly on top of the bottom. Right rectangular prism. Because we have the top and the bottom being parallel and congruent to each other. All right. The next figure, again, there's two circular bases, one on the top and one on the bottom. So we say this is a right circular cylinder. Okay. Number 3. Okay, we have a pyramid here. And this looks like we're gonna have to go by looks. It looks like this side is a little bit longer than this side, so I'm gonna say it's a right rectangular pyramid. All right, and then on number 4, the vertex is directly across above the center of the circle. So this is what we call a right circular cone. Okay, so knowing the names is important so that you can go to the reference sheet and figure out what we're going to do. So we need to know these names so that we pick the right formula. All right, let's take a look at now the next part. We have a three-dimensional figure, and they want to know how many faces, vertices, and edges are there. Faces. So faces are flat surfaces. In this figure, all of the flat surfaces are rectangles. So you have a top and a bottom base that are rectangles. You have a left side and a right side that are rectangles, and then you have a front and a back. So that there is a total of 6 faces on this figure. Vertices, these are the corners, 1, 2, 3, 4, 5, 6, 7, and then there's this one in the back you can't see. So there are 8 vertices. And then finally edges, 1, 2, 3, 4, those are the line segments. 5, 6, 7, 8. Those are the edges on the top and the bottom. And then you have these lateral edges, is what we call them. The ones that are going straight up and down that connect the bases. There are 4 of those. So I have 4 top base edges, 4 bottom base edges, and 4 lateral edges. That gives me a total of 12. Now, these problems you should definitely always get right. And if you remember one thing, and that is that the faces plus the vertices minus the edges always equals 2. Let's check. 6 faces plus 8 vertices minus 12 edges. Does that equal 2? 6 plus 8 is 14. 14 minus 12 is 2. Yes. So you can always check to make sure that that is correct. All right, let's take a look at this one. This one's a little harder. This one's got a lot going on here. Let's see if we can do this one. Faces. All right. So we have a top face right here, but we have another top face right here. Okay, and then we have a bottom face. So 1, 2, 3 for the top and the bottom. Then we have these vertical faces, the one on the left, the one in the middle, and the one in the middle. Okay, so we have three, we have 1, 2, 3 base faces. Then we have 1, 2, 3 vertical faces. And then we have this L shape in the front and L shape in the back. So there should be 8 faces total. Those are 8 flat surfaces. So don't think you can separate this and these are 2 separate ones. They're not. This big L in the front is an entire face. It's not 2 faces put together. One face in the front and then also one L in the back. Okay, and then you have this one on the top, this one on the top, and then this one on the bottom. And then you have this one vertical, and this one on the right side vertical. So that gives you 8. Now the vertices, those are the easiest ones to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 vertices, and then edges, those are the line segments. 1, 2, I'm going to count the ones going up and down first. 1, 2, 3, 4, 5, 6. Now I'm going to count the ones going left and right. 7, 8, 9, 10, 11, 12. And then I'm going to do the ones that are kind of going like this, 12. So 13, 14, 15, 16, 17, 18. All right. So 8 faces, 12 vertices, and 18 edges. I'm going to do that one more time just because that was tough to probably follow. So I'm going to do it one more time. On the faces, you got this one on the top, this one on the top, and this one on the top. So that's 3. Then the ones kind of going left and are on the left, right, in the middle. 3, 4, 5, 6. And then the front L and the back L. That's 8 faces. Vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then edges. I'm going to count the ones going straight up and down first. 1, 2, 3, 4, 5, 6. The ones going left and right. 7, 8, 9, 10, 11, 12. And then the ones going kind of like this towards you. 12, 13, 14, 15, 16, 17, 18. So let's check. Faces plus vertices minus edges, does that equal 2? 8 faces plus 12 vertices minus 18 edges. Yep, 8 plus 12 is 20. 20 minus 18 is 2. So again, you can check your answers on this one and know if you're right if you just remember this rule. Okay, this is called Euler's rule. This rule is named after a famous mathematician. You might think it's Euler, but they say Euler. This is Euler's rule. Euler's rule. Bases plus vertices minus edges equals 2. All right, let's take a look at now some surface area questions. Number 7. Okay, on number 7, we are asked to find the surface area. Remember, we do have a reference sheet. So the surface area of this figure, there are 2 bases plus perimeter times height. 2 base areas plus perimeter times height. All right, so again, we can dash this just to make sure you see there's a top rectangular base and a bottom rectangular base. So the base area is length times width or base times height. That's 10 times 5. Okay, now the perimeter of the base. Okay, so remember, if this is 5, this is 5. If this is 10, this is 10. So the perimeter of the base is 10 plus 10 plus 5 plus 5, which is 30. So the perimeter of the base is 30. And then the height of this figure, again, remember, height doesn't necessarily mean the one going up and down. It means the distance between the bases, 7. Okay. So remember, just in case, this is a dot. That means multiple, I mean, a multiplication belt. So 2 times 50 is 100. 30 times 7 is 210. So the total area, surface area is 310. Okay. So there is the total surface area, 310. All right, I'm going to zoom out just a little bit because these diagrams are just a little bit bigger than some of the other problems we've done so far on this review. All right, let's take a look now at number 8. Okay, number 8, we have, again, a prism, but be careful. The prism, meaning that this right here, this right triangle in the front and right triangle in the back, those are the parallel and congruent bases. So this is a right triangular prism. Okay, this is a prism with a right triangular base. Now, remember, it's still a prism, so we're going to use the same exact formula, twice the base area plus the perimeter of the base times the height. So base area, this is a triangle. Area of a triangle is base times height divided by 2. 80 times 60 divided by 2. Okay, now this time we have a little bit of a problem. I don't know all three sides of this right triangle here, but it is a right triangle, which means we can use the Pythagorean theorem. So I'm going to call this side C because it's directly across from the right angle. So 60, I'm sorry, let's try this again. 60 squared plus 80 squared equals C squared. 60 times 60 is 360. 80 times 80 is 640. 360 plus 640 is 1,000. Oh, I'm sorry. 3,600 plus 640. I knew something wasn't right there. 60 times 60 is 3,600. 80 times 80 is 6,400. 3,600 plus 6,400 is 10,000. So now we're going to take the square root of 10,000, which is 100. So this side is now 100. So now 60 plus 80 plus 100 would give me the perimeter of the base. 60 plus 80 plus 100 is, well, this is 140, so that's 240. So 240 is the perimeter of the base. Now the height, remember the height is not 60. It's not how tall the figure is standing as it's drawn. It's the distance between the bases, the parallel and congruent bases. So the height is 40. Okay. All right. So let's see here. We're going to do our calculator. I'm going to do first 80 times 60 divided by 2. And then we got to multiply by 2. So the twice the base area is 4,800 plus, okay, now we're going to do 240 times 40. Which is 9,600. And so now I'm going to add them up. Is 14,400. And I didn't realize this on the last problem either. I didn't do this. Since they did give us inches, this would be inches squared for surface area. Volume is in cubic units. Surface area is in square units. So this is 14,400 inches squared for this answer. Okay. All right, let's continue on with number 9. Number 9, we're asked to find the surface area of a right circular cylinder. They did say answer in terms of pi. So just like the prism, the cylinder has the same formula as the prism, twice the base area plus perimeter of the base times the height. So area of a circle is pi r squared. So 2 times pi r squared, pi times 3 squared, plus, now we have to do perimeter. Now, perimeter and circumference essentially mean the same thing. The distance around the circle is like the perimeter of the circle or the circumference of the circle. You learn that circumference is pi times diameter. So pi times, it's not 3, it's 6. So the circumference is 6 pi. So perimeter of the base is 6 pi. The height of the cylinder is 6. Okay. So 9 times 2, 18 pi. 6 times 6, 36 pi. So the total surface area, 18 pi plus 36 pi, these are like terms. So you can combine them together to get 54 pi centimeters squared. Okay. All right, now let's take a look at number 10, surface area of a sphere. Surface area of a sphere, this is again on your reference sheet, 4 pi r squared. Our r value is 6, so 4 pi times 6 squared. So using my calculator, the calculator, we're going to 6 squared is 36 times 4. So I get 144 pi. And this is in feet squared. Okay. All right. A few more to go through, and then we're done. Number 11, surface area of a cylinder again. So we have our formula is twice the base area plus perimeter of the base times the height. Okay. So circle is pi r squared. So 2 times pi times 8 squared. All right. Plus perimeter of the base. Remember, that's like circumference. Circumference is pi times diameter. Our diameter, if the radius is 8, the diameter is 16. So the circumference is 16 pi. So that's the perimeter of the circular base. And then the height is the distance between the two circular bases, 23. All right, so I know 8 squared is 64. So 64 times 2 is 128 pi. Okay, then I got to do 16 times 23. That's 368 pi. And again, we have like terms, so I can add them together. 368 plus 128 is 496 pi, and this is in meters squared. All right, continuing on. All right, so surface area of a prism again, top and bottom are parallel and congruent. So this is a prism. So it's just like a cylinder, twice the base area plus perimeter of the base times the height. All right, base area, this is a parallelogram, so base times height. So that would be 11 times 14. Okay, now we have to do the perimeter of the base. This is 11, this is 11, this is 14, this is 14. So the perimeter of the base would be 11 plus 11 plus 14 plus 14, the four sides, add them up. Okay, so 11 plus 11 plus 14 plus 14, which is 50. So the perimeter of the base is 50. And then the height of the prism is 16. All right, so 2 times 11 times 14. 2, whoops, I'm sorry. 2 times, I'm messing that up. Let's try that again. 2 times 11 times 14. So this part right here is 308. 50 times 60, or excuse me, 50 times 16 is 800. And then 308 plus 800 is 1,108. And this would be in inches squared. All right, continuing on. 2 more left to do here. Number 13. So on number 13, we have a prism. Be careful here. It's a prism. Okay, and in that prism, we have a front base and a back base, okay? So twice the base area plus perimeter of the base times the height. Okay. The triangle is base times height divided by 2. Base 18, height 10 divided by 2. Okay. Now perimeter. Now notice how this is 18 and this is 18. So the perimeter is 18 plus 18 plus 18, which is 54. Okay, perimeter of the base. Okay, and then the height of the figure is 12. All right, so you can do 18 times 10 divided by 2 and then multiply by 2, you get 180. Okay, and then 15 times, or excuse me, 54 times 12 is 648. Okay, so 180 plus 648 is 828. And this would be in centimeters squared. Okay. And number 10, or excuse me, number 14, sorry. Surface area of a sphere. The surface area is 4 pi r squared. So in this case, r is half of the diameter. So that would be 14. So 14 squared times 4. 14 squared times 4 is 784 pi inches squared. All right. Okay, I just realized that they don't have any pyramids and cones on here. So I'm going to just add 2 more problems. You don't have to add them if you don't want to, but because your assignment only goes here, but I'm going to go ahead and add 1 more just to make sure. So let's suppose I have something like this. Okay, that. So we have a square pyramid, and let's say each side of the square base is 6, let's say 6 meters, and then the height of this is not height, sorry. So on a pyramid, you need the slant height. So the slant height of this figure then would be, um, let's say it's 5. Excuse me, let's say it's 4. Okay, 4 meters. All right, so that's given in the problem. This is the problem. A pyramid with a square pyramid with a base edge of 6 and then a slant height of 4. So pyramids are a little different. So surface area of a pyramid is base area plus 1/2 perimeter of the base times the slant height. Okay, base area is pretty easy, 6 times 6 plus 1/2 perimeter of the base. So the perimeter, we have 4 sides that are equal on a square. So the base area is 24, or the perimeter of the base is 24. And then the slant height is 4. Okay. So 6 times 6 is 36. 1/2 times 24 times 4. So 24 times 4 divided by 2 is 48. So then 36 plus 48 is 84. So that would be 84 meters squared would be the surface area of that square pyramid. And then let's do another one, number 16. Number 16, let's do a cone now. So I'm going to do a right circular cone. All right, and let's say we'll say the diameter of the cone is let's say 14 centimeters. And then the slant height of the cone is 25 centimeters, like that. Okay. So same formula as a pyramid. Base area plus 1/2 perimeter of the base times the slant height. So base area, be careful. The radius is not 14, it's 7. So pi times 7 squared plus 1/2. Now, perimeter of the base, that's basically a circumference. Pi times diameter, pi times 14, 14 pi. So the perimeter base is 14 pi. And then the slant height is 25. Okay, so 7 squared is 49 pi. Okay, now I'm going to do 1/2 times 14 times 25. I'm going to do it in this order. 14 times 25 times 1/2, which is the same thing as divide by 2. So that's plus 175 pi. So the total surface area of this cone, 175 pi plus 49 pi, is 224 pi. And this would be in centimeters squared. All right. And then finally, I'm going to add one more, just in case it appears on your test. So we need to talk about the surface area of a hemisphere. So I have half of a sphere. Okay, so the surface area of a hemisphere is kind of interpreting. If it only is talking about the dome part would be half of a sphere. So the surface area of a sphere was 4 pi r squared. The dome part you would cut in half, but sometimes it also includes the bottom part. So then you would have to add a circular base of pi r squared, like that. So this is the dome, this part up here, and then this is the circular base. Okay, so let's say I'm telling you we have a radius of 12 meters. Okay, so let's say it's like an igloo. Okay, 4 pi times 12 squared divided by 2 plus, whoops, plus pi times 12 squared. Okay. So 12 squared is 144 times 4 divided by 2. So the dome part is 288 pi. Okay. And then the circular base is 12 squared, 144 pi. So the dome part is 288 pi. The circular base is 144 pi. So the total surface area of this igloo-like figure, which is a hemisphere, including its base, that would be 288 plus 144. So this would be 432 pi, and this is in meters squared. All right, so that should cover everything that will be on your quiz on three-dimensional shapes, volumes, and surface areas. All of these are important. Please remember when you are taking your test, use your reference sheet. Think about what shape is this figure and find the formula for that shape on the reference sheet. And make sure you're finding the right one. Are you looking for the volume formula? Are you looking for the surface area formula? Make sure you're thinking carefully before just writing something down. All right, good luck on your test.